Welcome everyone. So this is Boumediene Hamzi, and on behalf of the organizers, I would like to welcome you to the first symposium on machine learning and algorithmic information theory. It is hosted by the Alan Turing Institute. The epistemological context of this event is the question, how to analyze complex systems. There are many approaches that allow to analyze complex systems, and among the current ones is algorithmic information theory that was developed in the 60s by Kolmogorov, Solomonoff, and Chaitin, and it allows to characterize concepts like complexity, simplicity, randomness, induction, and the information context. But it is currently limited due to the fact that it's hard to compute quantities like Kolmogorov complexity that appear a lot in the theory. Another approach that is quite popular nowadays is machine learning, which is concerned with algorithms designed to accomplish a certain task whose performance improves with the input of more data. It allows to analyze some very high dimensional complex systems on the basis of data when the model is not even known. Among its current limitations, that it's mostly a set of techniques and algorithms. The theory is still underdeveloped, and it's not clear why the algorithms work and what is their domain of applicability. And another finally approach is the theory of dynamical systems that allows to analyze complex systems when the model is known. It was developed in the late 1800s by Lyapunov and Poincaré, for instance, and it offers non-trivial ways to analyze dynamical systems. It has the status of theory, but it is currently limited to low-dimensional models. So the object of this research interest group that I'm leading at Turing Institute is the interface between machine learning and dynamical systems. So the goal here is to fill the gap between machine learning and dynamical systems in the following directions. The machine learning for dynamical systems, where the goal is to analyze dynamical systems on the basis of observed data rather than attempt to study them analytically. So this would allow to extend the boundaries of the classical theory of dynamical systems to high-dimensional systems. And the other direction is dynamical system for machine learning, where the goal is to analyze algorithms of machine learning using tools from the theory of dynamical systems. And this would allow to give solid foundations to the existing methods, understand their true potential and limits. So here one would look at machine learning algorithms as dynamical systems, where time is the time in the computer, not necessarily in the clock, like in the case of dynamical systems. And then this would allow to identify the domain of applicability of the algorithm in machine learning. On the other side, the goal of this symposium is to explore the interface between machine learning and algorithmic information theory and fill the gap between these two areas in the following directions. The first direction is machine learning for algorithmic information theory, where the goal is to explore applications of Solomonoff induction, also explore algorithmic probability approaches to probability predictions, and explore the links between information learning and data compression, and also developing or using machine learning algorithms for better compression and prediction, trying, for instance, to approximate Kolmogorov complexity that appears a lot in AIT. The other direction is algorithmic information theory for machine learning. And here, one would be interested in looking at machine learning algorithms as complex systems, where one would apply tools from algorithmic information theory. And here, the goal is to identify the domain of applicability of certain machine learning methods and explain, for example, why certain methods in machine learning will a priori work so well for certain problems, or a priori will not work for other problems. And so this would allow to explore this domain of applicability of algorithm machine learning and give solid foundations to the field. So personally, I got involved in AIT just relatively recently, about 2 years ago, where I was interested in exploring Kolmogorov complexity for machine learning and dynamical systems, through discussions with one of the organizers, Kamal Dingel, and also with Mark Fussi, through discussion, more recent discussion during the last year. And so this is, and then it turned out that the interface between machine learning and AIT is not very well explored. So and so the idea of organizing this symposium. So to get more details about this research interest group on machine learning dynamical system, you can check the website on the Turing Institute. The talks in this symposium will be recorded and posted to YouTube. So if you do not want to be in the recording, then please have your video turned off. We will be editing a special issue on machine learning and algorithmic information theory in Springer's Mathematics in Computer Science, and more details will follow. For updates about future activities on machine learning and AIT, you can fill the form on the following website, so the website of the symposium. And yeah, finally, for those coming in person, the Enigma room is available strictly between 10 a.m. and 4 p.m. And then at 4 p.m. we'll have to leave the room and then go to the coffee shop or the British Library for discussions. And yeah, thank you all. And I'm looking forward to learning from all of you about this area. Yeah, thank you.